Hello, peoples of the internet. My name is William. Some call me the Math Hatter. I apologize for my prolonged absence. I hope you've all been keeping up with the homework while I'm away. That's a joke. I don't believe in homework. So, I wanted to discuss a few things in the mathematical arena before we continue on. Obviously, not some major theorem, but just, a reminder of what we've already been through and what's coming up. So we've already done quite a bit on linear systems. So that is, you put in a number, you multiply it by something, and you add something, and you get a result. And sometimes you do this again, and you get what is hopefully the same result. So we've already covered that in the previous videos. So for now, what I want to talk about, which will help when we get into more complex situations, domain and range. These may look like scary words. I'm here to assure you they are not scary words. So if you remember, our previous plot went something like this, where we put in x down here, and we got out a y. Now here's the key. X is the domain, so it's whatever we can put in. Y is the range. It's whatever we can get out. So it's not just a number. It's not even so simple as a collection of numbers. It is an entire stream of numbers, each of which we can pick. So earlier we would be doing something like 2x plus 1 is y. And we get a result like that. We can put in any x we want. But how do we write that? How do we express that in tangible mathematical terms? We say that x belongs to, this is a very fancy math symbol known as belongs to. Don't worry, it looks strange. You'll get used to it. It is your friend. It does not wish you harm. The set negative infinity to infinity. This is just a simple way of saying you can be as big as you like that way, big as you like that way, doesn't matter. Because infinity is not a real number, it's just because you can never count to it. Numbers are what you can count to, you can calculate with them, you can make some sense out of them. Infinity doesn't really work like that. So we just use that as a symbol as, yeah, go as big as you want. I don't care. The range, the result, well, we can obviously see if we squash the line that we're working with to the y line, it can be whatever we want as well. So y belongs to the set negative infinity to infinity. And it's as simple as that, really. So what does this mean? So this is the domain of the function. And we can write it over here too. Saying that something is f of something as opposed to just y equals will be helpful later, but the range is the same. Now, these brackets around are very important to get correct. This means does not include, because when you're talking about infinity, you can't include it, because that would mean that you're excluding like infinity plus 1 or whatever, and that just infuriates mathematicians. So we say that this parentheses means does not include, but this one means it does include. So round brackets does not. Square brackets does. Let's change things, okay? Let's say I want all the x values from -2, let's say, up to 5. for whatever reason. I just only want to look along this set, this specific set. And more importantly, I don't care about -2, but I do care about 5. So how will we write that? And what would the range be? Because remember, this is a defined domain. We're taking all the numbers that we want and then applying. That's the domain. And then what is the range? Okay. So with what I just talked about, with this means I do care, and this means I don't. Because I don't care, it gets the round brackets, -2. That's at the bottom. And then up at the top, the very limit at the top is 5. And I do care about 5, so I put square bracket. Okay, so what is the range then? Well, this can be found very easily in this case. We just put in we put in the absolute ends and see what the absolute endpoints get. So 2 times -2 is -4 plus 1. So we move 4 to the left, we move 1 back right, we get -3 because we're still 3 to the left. -3. Do we care about -3? Well, we didn't care about -2, so that's a no. So it stays round. 5. What's 2 times 5? 10. Add 1. 11. Do we care about 11? We do care about 5, so therefore we do care about 11. So it gets the square bracket. And that's it. It's that simple. For now. It will get slightly less simple later, but not to worry about it. This is a great tool to know how to talk about, here's what I care about in this particular function. Or here's what this function can be for some defined values. It's a really helpful tool. It's going to be brought up quite a bit later. But for now, this was mostly just a simple, get back into things after 7 months of not doing this. Sorry, hi. Just trying to get back into the flow of things. And this will help you too a lot, I promise, as we get further out and further into the mathematical brush. So, that should do it for today. My name is Ben Williams. Some call me the Math Hatter, and I will see you next time. Bye.